would like to introduce the first speaker for today, for this session, Alexandre. And he is currently working as a data scientist in the detection team at the National Cybersecurity Agency of France. So with this, Alexandre, welcome.
Hello. Do you hear me well? Yes? Perfect. So first, I'm really grateful and pleased to be part of this conference and to be in front of you today. As you've already probably noticed, I'm French. My name is Alexandre Junius, and pardon my English, I will do my best to be clear. Today we are going to talk about machine learning and specifically anomaly detection used in detection of malicious activities in command lines. So to give you a quick look at my presentation structure, we will start by an introduction about the data, where it is from, what is it about, how can you use it, what are the common methods used to detect intrusion in this data. And then we'll dive into the statistical modeling. I will try not to make too much of mathematics, but I like to explain how the statistical modeling has been done as to break the black box sensation we have sometimes with machine learning. And so I will talk about Markov chains and n-grams. And then I will present to you our open source tool. It is free. It is available on GitHub. And I will give 2 demonstrations on how to use it. And finally, I will conclude about how to generate alerts for your SOC teams. First, who am I? I come from a statistical study in an engineer school. And I wanted to say that because it means that I do not come from the cybersecurity field, nor informatics field. But I've learned how to talk with a cybersecurity specialist. During the 3 years in the National Cybersecurity Agency of France, I am part of a team of cybersecurity specialists. I am not part of a team of data scientists. I am the only data scientist in the team. And they give me the intuition of how to detect intrusion in our logs, and I try to translate it into machine learning algorithm or simple statistical algorithm. And our team focus on detecting intrusion in endpoint logs, so I will not talk about network logs, for example. So what is it all about? We are collecting a lot of Windows event logs. The Windows event log looks like that. If you open your event viewer in a Windows operating system, you will see this kind of window, and you have a lot of information inside of this event log. We are going to focus on one specific type of event log, which is the new process creation. Each time a new process is created on your operating system, you have this kind of event log. And we see that there is specific data inside. You have the username, the host name, the timestamp, and what we are going to be interested about, the process command line associated with the launch of the new process. So how can you retrieve it on your company system? Well, first, the simplest way is to make sure you have enabled the audit process creation in your audit policy. Normally, it is activated by default, but make sure it is activated. And you have to enable the command line logging in your configuration. The other way on Windows is to deploy sysmon that you maybe know. And the first event of sysmon, the event ID 1, also tracks a process creation and gives some more details rather than the Windows security. You have, for instance, the parent process command line that you will not get in the Windows Security 4688. And you can, if you have some Linux system, you can also monitor the logs. It will be the same model. How do we do nowadays to work with this kind of logs? Well, we have 3 main ways that still works, and we are not going to try to replace it. The first one is looking for IOCs. For instance, in the process creation logs, we are going to find malicious hashes for specific processes. We can also create signature for known behavior. For instance, you have the Sigma frameworks that give some detail on how to structure your signature. And this is a way to say, for instance, Word.exe has launched another process that we know is malicious. And this is a way to detect this kind of behavior. If you know some behavior of some attackers group, you can create specific sigmas. And eventually, if you know really well your company system, if you know the normal volumetry, the hosts that are able to connect on other one, you can create custom alerts in your SIEM, and that can also work. All of this works really well on known behavior. But there is also a field for unknown behaviors, intrusion that we have never seen, but that we can say statistically that are really abnormal. And this is what we are going to talk about, statistical learning to detect unknown behaviors, and specifically in command lines inside the event logs. Now that I've given all of the context, we can dive into the modeling and dive into a bit of math. First, I have to define what Markov chains are. I will first give you the real definition, which is it is a stochastic process whose prediction of the future from the present is not made more accurate by the past. Everything is clear here? Okay, no, it's not clear like that, so I will give you a quick schema to understand it well. First, I've done this little graph with probabilities, but my colleagues have told me that it was not really clear. And to make it clearer, I had to put cats, and then everything is clear. You'll see. So let's say that we want to modelize the behavior of a cat during his day. We will make the hypothesis that a cat has only 3 states: sleeping, eating, and running. You will observe your cat during days and days and compute the probabilities of transitioning between one state to another. So here we have our trained model, and we see that there is, in 60% of the cases, the cat has first sleep and then he has been eating. And so this is the model that has been trained during days and days. Then what do we do with this kind of model? When we can detect if another animal, by observing it after, is likely to be a cat or not. How to compute it to be likely or not? Well, we have a definition in math, which is the likelihood, which is the product of the different probabilities. So let's say I have another animal after my model has been trained. This other animal first starts by sleeping, then he is sleeping again, and then running. So it makes 20%, and then also 20% sleeping against running. We make the product of this probability, .2 times .2, it makes it 4%. So it is not really likely to be a cat, but we don't really know. We can say with just one likelihood if it is abnormal or not. Then we have a second animal, which starts by running, then eating, and again eating. So this time, this is .7 and .6. We see that the product of the probability is here .42, and it is higher than the first likelihood. So what we can say is that the second animal is more likely to be a cat than the first one. So maybe the first one was a dog or another animal. This is really important to understand that we can only compare likelihoods, and we will talk again about likelihoods after, and you will see that we will only compare likelihoods. But now, how do we apply Markov chains to the study of command lines? Well, we have to explain another concept, which is n-grams, which is a way to cut command lines into parts, and these parts will be our states of the Markov chain. So we see here we have a first command line. We have started to cut it. You see in blue, we are doing a 4 grams, which means that we are cutting in groups of 4 letters, and we are observing the letter just after the n-grams. So the model has started training, and we see that we have already see CMD. As a first n-gram, and the letter after has been E 100% of the time. And then we progress into the command line, and we have different n-grams and letter after the n-grams and different probability updating. This is the first command line, but you have to understand that there are a lot of command lines passing through the model during the training, and the probability updates each time. We see here we have another command line started with CMD dot, but this time this is CMD.jar. So the probability here has been updated with CMD dot, and 50% of the time we have seen E, and the other 50% of the time J. And this is the only thing you have to understand the modeling behind AnoMark. Now, how do we train it with the tool that I will detail later? Well, this is simple. You just take your logs within your system, and you cut it in 2 halves. The first one will be the train dataset, and the other one the test dataset. With the first dataset, with the train dataset, you will apply AnoMark on it. It will learn on the command lines. It will try to read all of them and learn the way of reading them, the normal way to reading them. And it will produce a pickle file, which is a way to store a Python class. Now that you have trained your model, you can apply it on other data, your testing dataset. You apply AnoMark with the pickle file produced in the first way, and AnoMark will sort command lines by likelihood. As I've said, we can only compare likelihoods, and so we will have first the less likely command lines, and then the more likely command lines. And we hope that the less likely command lines are intrusions. So to give you first some example of what AnoMark can detect, because we have been using it for practically more than a year now, we've seen a lot of detection of encoded command lines, which is logical because of the encoded part, which is quite random for the modeling. And if the encoded block has never been seen, AnoMark will give a really low score of likelihood. We also have the ping with unusual domains, because we see that a lot of the part of the command lines is unusual. And also a non-process execution. If this is the name of a process that we have never seen, well, AnoMark will give a low score also. But all these 3 types of command lines could be detected with the Sigma framework, or maybe with IOCs for the unusual domains, for instance. So this is not where AnoMark is the best, where it really is complementary to other kind of detection. There are other command lines that are more interesting. For instance, unusual flags. So this is a known process, but using unusual flags. It could be a process that has been renamed, for instance. We've already seen that. And if you just whitelist the process, you will never see the command lines, but AnoMark will see it. Small changes in the letter, because AnoMark is case sensitive. So if you have some case changes during the command lines, it will also see it. And finally, non-processes, but executed from unknown path, and AnoMark will detect the path, the folder before the processes. Now, I will talk a bit about our open source tool because, as I've said, AnoMark has been published last year on our GitHub page, so you can retrieve it. It is written in Python. It is really low memory consumption. It has been made to be easily installed on every system, and we've also provided a Splunk custom command for those of you that use Splunk, and I will showcase the use of the command just after. If this project is open source and if we want to talk about it in conference, it's because we think that there is a real interest for us to have some feedback, so don't hesitate to contact us about AnoMark. And we do not provide a model trained because AnoMark is an unsupervised learning algorithm and it is system specific. You have to train it on your own logs on a specific time range, practically a month or so, and then you can apply it on your system. So we do not provide a model already made. There are two main ways to use AnoMark. The first one is post-mortem analysis. If you have retrieved from an incident response team, for instance, some data of a system or your own system, you can analyze the logs, as I've showcased before, by dividing it in halves. You train on a part, you apply it on the other one, and you can do it in both sides. And it can also, and in my team, this is what we are doing, it can also help SOC team during their everyday monitoring and generate alerts on everyday logs. I will try to make a quick demonstration, if it works. Yes, this is a video. So this is the structure of the open source project. You'll see that you have some Python file, but not so much. I have put two data files, one testing, one training. You'll see that inside there are command lines and process name, raw text. We train it on the data by providing it the order of the n-grams. So here we are doing it with the 4 grams. This is the length of the groups of letters, as I've said before. The name of the variable, here it is command line, and the name of the output model. It will be training. It is quite fast because this is a low-weight model. And then you can apply it on your test data. And you see that when you use it in the shell, you have some letter coloration. The red letters are the most unusual ones. This is to show the bias of the algorithm because it is statistically trained. There are some bias. And you can see how it has been trained by reading the red letters. So here, for example, we see that PowerShell.exe has already been seen in the training data set, but for instance, host name has never been seen. This is sample data, fake data, so it is normal that some usual commands has never been seen. But you see that you can explore the result with this coloration to see what the bias are in your training. Then I will show how to use it in Splunk, and this time this is live demo, so I hope everything will go well. So for those of you who already know Splunk, I've started to make a quick query. I am filtering on 4688 event IDs, so these are the Windows security process creation logs. To apply AnoMark, I have already installed AnoMark with the custom command app that we provide in the GitHub page. And to apply AnoMark, you just have to make pipe AnoMark, and it will apply on the data. And you see that there is the creation of a field which is called Markov score. So we can also sort on this score because we want to see first the less likely command lines. We have some empty command lines, so we have to filter it. We say that there is something in the command line. This is better. And we start to see some unusual command lines. It will process a bit. And we can explore it and pivot on the data directly into the SIEM. So here, for instance, we have the first result on the data. You see the first command lines, the first unusual command lines. Some execution, some CMD. And we'll also see, normally, in the second page, that we have a lot, for instance, here, of this most. And because we can query quickly, we can filter new process name. Not, and we say this most. And launch it again, and it will, little typo. And we can use it like that and iterate through the data to go through all our command lines. And, I should have made easier. Magic. Yes. Okay, I know myself, I knew that I would make mistakes. So. And then you have your data with a little bit of whitelisting, and you can explore it and see the most unusual command lines compared to the trained period of time. Now I will conclude on how to generate alerts for your SOC team. And this is what my team tries to do on everyday work. So imagine this time you have trained you want to train your model one time, and then every day apply it on the new logs and to generate alerts on the most unusual command lines. We have to find a way to not throw 100 command lines each day to the analyst team, because we have a lot of different systems to supervise, and we do not want to make it every day 100 command lines. So how do we do it? Each day, we launch AnoMark on the data indexed the day before. So the data we have received the day before. We select for this day the top 100 most unusual command lines. But we do not want to make it all alerts, because we want to filter it a bit. So to select within this top 100, we compare it with the alerts of the 30 past day, or the months before. And we see which alerts of today can enter in this historic of 1 month. To make it schematic, it is like that. So we see that each day we have 100 command lines. But for the D-Day, the top 100, the score of the 100 command lines of the alert historic is at minus 5.4. So if we have a command line that has a score higher than minus 5.4.4, we will not create an alert. And if it is lesser, we will create an alert. We only take the months before just to not get one day a guy typing random thing, polluting the alert historic, and we will not generate alert for the future. So with this window of 1 month, we can generate new alerts and have a dynamic threshold. A threshold that, because we cannot give a percentage of maliciousness of a command line. So as a conclusion, I would say that this kind of algorithm, which is not the most sophisticated one, it is not ChatGPT. It is simple statistics from the 70s, but we've seen that it works on real data. We have tested it in the National Cybersecurity Agency of France, and we've already detected some malicious behavior with this kind of algorithm. And we are able to say that there is a way to detect intrusion with anomaly detection algorithm. It is a proof that it works. And maybe it could be with Markov chains again or not. But it is a great example to detect unknown behaviors. Thank you, and time for the question.
All right, questions. I noticed you first, so you go first.
Sorry for pushing ahead. I would be really interested to know, like, the false positive rate initially and how it evolved over time. Like, yeah. So alert fatigue versus success of the system.
Yes. The false positives rate is something that we have some difficulties to estimate because there are command lines that are not related to intrusion in the system, but that are command lines that we want to see. There are bad habits of administration, and we want to be able to tell, do not do that. And this is unusual because this is not a good habit. But on post-mortem analysis, we have been able, on the top 100, to get 50% of command lines that were related to the intrusions.
Sorry. I would also have a similar question. Have you tried benchmarking it against like a normal parser where you know if there's like an entropy checker to see if there's obfuscated command line code versus the actual command lines that you want to detect that as bad administration? Have you benchmarked it against such a tool yet to see how well it performs against it?
Benchmark against what tool? Sorry?
A set of parsers, for example, detecting entropy. So seeing if there's obfuscated lines of code, or again, like your bad administration example, have these parsed through and see how well your AnoMark fares against that.
We've not benchmarked it against some parsing tool, but the truth is that on encoded command lines, for instance, or this kind of command lines, AnoMark will do just as well as other parsers. But there are other command lines that are interesting, like unusual flags, as I said. And I have also been able to benchmark it against deep learning algorithm to see if there was a real interest to make a deep learning one. The deep learning algorithm can make a little bit better, but this is not the same kind of server behind. You have to have a lot more RAM consumption. So this is the only benchmark I've already done.
Hi. Have you tried this against other things than command lines, like, I don't know, service names or other types of artifacts in a system? And do you have any experience with that?
We have tried it on scheduled task name, on services name. There is, on scheduled task and on services, there is not enough variety in the data, so it will get strong bias. But it can work on DNS data, on some URL or thing like that. Basically, everything that is text-related can work with AnoMark.
Okay. Can AnoMark detect multilingual command or path such as Japanese or Chinese?
That is to say, characters that are not French characters, for instance?
Yes, yes.
Yes, it can work, yes.
Oh, thank you.
Hi, thank you. Another question, would it also work on base64 encoded strings, like you just take the base64 encoded string for encoded command strings? Because there are a lot legit applications, or we see a lot of legit base64 strings. Would it work on that? Did you try that?
We've tried that when it is possible with the SIEM, when we can parse before the event. So there is another event that is created with the unencoded event logs. But we also have the encoded one, so sometimes it makes redundance. But yes, it is a good way to reduce the false positive rate when you can decode online the command line.
I will have a question from my side. So this is when we have time and chance to kind of train and learn over a certain period of time.
Yes.
But not always we have the luxury. Sometimes CERT is incident responders are deployed on site and they have to work with whatever is there. We already mentioned post-mortem. Have you tried post-mortem and analysis, just feeding in the logs and seeing what comes out? What would be your take on this?
When I do not have the choice, I can take a model based on another system, another organization. But the best is to use it with data from the system. And so even if I say that it is good with 1 month, even if we have 1 week or 2 weeks of data, we can try to make it live.
All right, and we had a chat right before you came up on the stage, and I asked you about, that you just mentioned that this is pretty much Windows logs, and I said now Windows runs also Linux in the Windows subsystem for Linux. What was your answer? Can we track that as well?
It is also logged, yes, in the 4688 event logs, so we also see Windows subsystem, yes.
Now, with a Markov, you can't tell which is a malicious command and which is a benign command. You can see which commands are just standing out from the past baseline. Now, you mentioned that in your talk that you don't provide the trained model, you download the software and you use it. In essence, would it be possible to train the model against known malicious set? Well, whatever that is, let's theoretically think about it. And then you run it against your command line history and see if the matches already previously known malicious. Like, let's collect it like MITRE attack framework, similar, just collection of bad commands.
It can work, yes. So it is the reverse thinking. So we try to get the most likely command lines to compare it with malicious command lines. It could work. We have never tried it. I've already seen it with PowerShell scripts, but never with command lines.
All right. Are there any more questions? If not, let's thank the speaker again. Thank you, Alexandre.